and I don't know why that's still up, but we are recording. Okay. And you want me to pull up the test?
Yes, sir, sure.
Okay, hold on just a moment and let me get to the test. And this was the second test, is that right? Okay. This is the one with the graphing and stuff like that, right?
Yes, sir.
Okay. All right. Let me see. You probably can't see it yet. Goodness, there's just so many moving parts here. Okay. There, can you see the test now? Okay, let me get this taskbar, which you can't see, out of my way so I can see the test. I'm also going to scoot you over to the right just a bit so I can see a little bit more of the test. Okay, what you got? What question?
Okay, so, alright. So your copy is
That,
different from the one that I printed off. Um, so on the first 9 questions,
right,
on question 2, 3, 5, 6, 7, on my test where you have a pi, like on number 2, the very end where you have a pi over 4,
right.
I just had a letter, like a capital letter B, and I had no idea what that meant. Like, I had no
Okay,
idea what I was doing.
all right.
So I guess now it makes sense that it's just supposed to be pi over 4.
Well, okay. Sorry about that. I have seen this happen before, and I blame it totally on PowerPoint. I mean, not PowerPoint, on Windows. Windows Word, okay? I'm sorry, I should say Windows. On Word, okay? On Microsoft Word. What they do, and it irritates me no end, this computer belongs to the college, okay? Uh, and it belonged with the people who run the, whatever you call it, distance learning. They issued me this computer to use, uh, and they have on it a version of Word. And Word does this, and it just irritates the fool out of me for them to do it. They will put something out there and make it incompatible with anything that came before. So they force you to buy the newest version of everything. I didn't buy this version. It came with the computer, but I've had in other classes, I don't think I've had it happen in this class before, that people could not access what they needed to access. But it has happened again. It happens in my calculus classes all the time. So what I'll do is I will do a PDF of this test, and then I'll load that one out there as well. And therefore, whatever you see on the page, that will be in the PDF. So I will do that. I don't know why Microsoft does it, except they're wanting to sell more product. That's all they do. I just really detest Microsoft as a company because they rip people right and left. Okay. When I typed this test, it was done in WordPerfect, but no one else can read WordPerfect. But you see, when I do it, here's a laundry coming in. Let me get a laundry marked here. Okay, there. Okay, and I apologize. I'm sorry that happened, but this was done a while back, so I will try to get that done. I'll try to get it done between 1 and 3 today. I've got class up until 12:45, and then I have another class starting. Here's Kelly coming in. Uh, Kelly's here. Um, I've got class up until 12:45, and then sometime between 1 and 3, I'll have some time. I'll probably eat lunch right after 12:45, so probably it'll be closer to 2 to 3 when I'll try to get the I have to take a picture with my wife's iPad and get a PDF of it, and then send it to myself, and then there's several steps in it, but I'll try to get it done so you'll be able to see what is supposed to be seen. I hate it that Microsoft does things like that, but they do. So sorry about that. Like I was saying, I always use WordPerfect. WordPerfect has a much better equation editor. It has for years. Microsoft copies everything they can from other people. They never have been able to get the equation editor right, and they just screw it up badly. Sorry about that, but I'll try to get the PDF out there for you. All right. Okay. Okay, the trouble is I'm going to have to move you folks out of the way so I can go to the right and scroll. There it is. Okay. Okay, did I go too far?
No, that's fine.
Okay.
Okay, so yeah, it's just supposed to be pi instead of the like on the copy I had. It just had a where a pi was supposed to be every time there was just a letter like a capital letter B, and I wasn't sure what to do.
Yeah, that's ridiculous. Why Microsoft does it, I don't know. Let me keep on going. How about the thetas? Are they showing up okay? Number 13.
What number?
Number 13, the second page.
Yeah, they're showing up.
See, why pi doesn't and theta does. How about the degree symbol on number 16?
It's there.
It's there, okay. Microsoft is just a sorry product. They're a sorry company, period. Okay. Okay, so it looks like everything else is okay. Okay. All right, but I'll still put it out there in case other people are having the same issues. Okay. All right, good deal. Okay.
I got one more question.
Okay, what's that?
So for physical science, you like drop down like lowest test grade or whatever.
Right.
Is it like are you doing that for this class too, or is this what we get? Is what we get?
Okay. Now, which physics? Okay, wait. You're talking about the the trig class right now.
Yes, I'm
Yeah.
saying like are you kind of doing the same as you did in physical science?
Yeah. Okay. If you'll go back in the syllabus list, your research paper is not droppable, and the final exam is not droppable. We'll have 4 tests in between. I hope will. I will drop the lowest of the 4 chapter tests if it helps your average. But the research paper is not droppable, and the final exam is not droppable. But the others, we've had tests 1 and 2. We are going to have a test on chapter 5, which we're making decent progress in, not great progress yet, and then we'll have a test in chapter 6. And of those 4 tests, I'll drop the lowest score if that helps your average. Okay, was that what you're asking?
Yes, sir.
Okay, good deal. All right. Okay, any other questions? Okay, and as I was saying before, in 5.2, which is where we are, there was only one example given on the PowerPoint. Again, PowerPoint is a pretty sorry product too, in my mind. And the rest of that wasn't Microsoft's part. It's just the book only put one example there. So we're doing all the rest of them on the whiteboard, and so we'll go from there. I'm going to get the PowerPoint started here from current slide, but this is, let's go to the whiteboard. Okay. Now I need to move some things around here. Why they put taskbars in the middle of the white space, or not in the middle, in the white space, so you can't access it, but you can't see it. I can, and it blocks what I'm able to write. So that's why I have to move things around. Okay. All right. Any other questions before we get started today? Okay. Today we're in Chapter 5, Analytic Trigonometry, in Section 5.2, Verifying Trigonometric Identities. Okay, we're on page 359, top of the page, example 6. Is that where you remember that we were? All right. I hear no objections, so I hope it's true. Now, in my last class, my pen quit working. Just right in the middle of things, it quit working. Hopefully, yeah, it seems to be working now. Okay, here's the identity we're asked to verify. Cotangent squared theta divided by 1 plus cosecant theta supposedly that's equal to, this is what we're trying to verify, 1 minus sine theta divided by sine theta. Now, this is a rather bizarre little problem here. And that sine theta here doesn't look very much like a sine theta. Okay, there. Now, obviously the left-hand side is a little more complicated than the right-hand side. Okay, but we can handle that, I think. Okay, now, this is one of those problems that you have a binomial in the denominator here, which usually is a good sign indicator to let's go on and multiply by its conjugate. Okay, the book doesn't use that term, but it's usually a pretty handy thing to do. On the right hand side, we can actually simplify that big time, and we may come back and do that. But let's do this now. So let's leave for right now cotangent squared theta in the numerator. Okay, now in the denominator, we're going to have a 1 plus cosecant theta, and we're going to multiply by its conjugate, which is 1 minus cosecant theta. Okay, now this is the first guess. No guarantee this is going to work. Well, I just changed the denominator, so I have to multiply by 1 minus cosecant theta in the numerator as well. Okay, now over here on the right, I'm going to suggest doing this. It's not necessary, but it's a good idea. You see, you have a monomial denominator, binomial numerator. Let's split that into 1 over sine theta minus sine theta over sine theta. Now, I don't know if that's going to be a good move or not, but it's certainly a legal move. Okay, so we'll come back to that in a minute. Okay, what this gives you on the left-hand side, 1 minus cosecant squared theta. 1 minus cosecant squared theta. Does everybody see that? You're foiling. 1 times 1 is 1. This will be a minus cosecant theta plus cosecant theta. That adds a 0, then a minus cosecant squared theta. Okay? And this, the numerator, is still cotangent theta times 1 minus cosecant theta, if I could write. Okay. Well, what is 1 minus cosecant squared? Okay. Now this is a form of the Pythagorean identity. Okay, I'm going to write, whoa, here comes Keelan. Let me get him here, admitted to the class, and marked on my roll book. Keelan is right there, below the blue line. Okay. All right, let me just make sure we've got everybody. There's nobody else waiting here. We have 10 students here already, don't have anyone obviously waiting. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 10 accounted for. And by the way, let me go on and say this before I forget about it. You do know what today is, right? Voting day. Okay. I hope you've already voted, but if you haven't, please make time between now and 7 o'clock this evening to go vote if you're registered and can vote. Please do so. My wife and I voted close to 2 months ago. Okay. It was nice, pleasant weather then. I'm so glad we voted. I didn't have to go out, and today I would have to go between 1 and 3 o'clock and stand in line. Of course, the temperature may be okay by then, but it was pretty chilly this morning, so I'm glad I wasn't have to stand there at 7 o'clock this morning trying to vote. So please vote if you can. Okay. Now, what I was just going to go is go over the Pythagorean identity again. Of course, the simplest version of this is sine squared theta plus cosine squared theta. Get to know this, folks, is equal to 1. Now, since we're coming up with a cosecant here, cosecant is 1 over cosine, right? So let's divide everything on both sides by sine theta, sine squared theta. So divide this by sine squared theta, this by sine squared theta. Okay, what do you have? 1 plus cotangent squared theta, which is sort of nice, is equal to cosecant squared theta. Okay, then subtract cosecant squared theta from both sides, and that's what you've got down here. So what would that give you? That would give you, if you subtract the cosecant squared theta from both sides, oops, here comes Jared. So let me get Jared marked here. Jared is just above the blue line. Okay, got it. So that should have us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Should have 11 students here. Let's see if we do. Yep. 11 students. Good deal. Okay. I was just, Jared, we're on we're in Chapter 5, Analytic Trigonometry, 5.2, Verifying Trigonometric Identities, on page 359, Example 6, top of the page, and that's the one we're working on now. And I was just pointing out to people the trig identity here, 1 minus cosecant squared theta, which now Damien's coming in. I've got Damien here, beginning to be a pretty good sized class today. Good deal. Okay. All right. This is sort of, okay, I've got too many papers stacked up there. Okay. What I was trying to do way back, and Damien, by the way, we're in Chapter 5, Analytic Trigonometry, Section 5.2. Oops, here comes, oh, Bennett must have had to go out and come back in, so, because I already had Bennett here. I think I did anyway. Yep, got him. So we should be 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think we're up to 12 students now, so let me see if that's true. Yep. And nobody else waiting. Okay. All right, so for those who've just come in, Chapter 5, Analytic Trigonometry, Section 5.2, Verifying Trigonometric Identities, on the top of page 359, Example 6, and that's what we're doing. So I'm trying to get this done, subtracting cosecant squared from both sides. So, because that's what we have down here. And then we would also subtract cotangent squared from both sides. Okay, here the cotangent squareds go out, here the cosecant squareds go out, and you have 1 minus cosecant squared theta is equal to minus cotangent squared theta. So this will be minus cotangent squared theta. All right, then this will go out with this, okay, leaving you a minus 1 up top. Okay, so we're going to deal with that in a minute. Over here, what do you have? 1 over sine is cosecant theta minus 1. Okay, over here we have a minus 1 times 1. That would be a minus 1. Minus 1 times a minus cosecant theta would be a plus cosecant theta. And these two are indeed the same. Cosecant theta minus 1, cosecant theta minus 1. So yes, no more question mark here. Those are the same identities. Now, the book probably did it a different way. Okay. In fact, okay. So they did their cotangent squared theta as the identity cosecant squared theta minus 1, which we sort of did. We went around the different way to do it. And then they factored cosecant squared theta as 1, or cosecant theta plus 1 times cosecant theta minus 1. They divided out the 1 plus cosecant theta, and that left a cosecant theta plus, minus 1, which is indeed the right hand side, which we got to as well, cosecant theta minus 1. So they did it slightly different order, but it still worked the same. As long as all the steps are correct, that still should work. Okay, any question on that? I know my writing is pretty ugly here, and I did the scratch work up in the upper right corner and didn't have enough room for it. But any questions on example 6? Every example is followed by a checkpoint. Please do the checkpoints. Those would be similar type problems. Okay, example 7 is also not done on the PowerPoint, so let's clear. Anyone need a question about this before I clear it? Okay, so I'm going to clear all that writing, and we'll do example 7, the bottom of the page. Verify each identity. There's actually 2 of these. The first one is tangent to the 4th power of x is equal to, or at least supposedly is equal to, tangent squared x secant squared x minus tangent squared x. Okay, that's the identity we're trying to verify. Is indeed that true? Now, I look at this, and the left-hand side does look pretty simple to me, so I'm going to leave that alone for now. It's just tangent to the 4th x. Over on the right-hand side, though, I see that I can factor out a tangent squared. So let's do that. Tangent squared x times secant squared x minus 1. Well, let's go back to that good old Pythagorean identity again. Remember, sine squared x plus cosine squared x. Get to know this, folks. You should have this down pat. is equal to 1. And since we want a secant squared x is 1 over cosine squared x. So we're going to want this to be divided by cosine squared x, which means this would have to be divided by cosine squared x, which means this would have to be divided by cosine squared x. This gives you tangent squared x, which is pretty nice to happen, plus 1, because cosine squared over cosine squared is 1, and that's equal to secant squared x. Okay, now let's subtract the 1 from both sides. And that disappears, and so you have tangent squared x is equal to secant squared x minus 1, so therefore let's make this tangent squared x, because that's secant squared x minus 1, and sure enough, that times tangent squared x is equal to tangent fourth x. And that's exactly what we've got here too. Tangent fourth x. Okay, any questions on that? Now, they worked with the left-hand side rather than the right-hand side. It's all equivalent. All equivalent. Both of them worked. All the steps were right. Okay, let's do the B part. Any of you need that a little longer? Anybody? Any questions? Okay, let's do the B part. The B part says secant fourth x cotangent x. Cosecant fourth x times cotangent x supposedly that's equal to, that's what we're trying to verify, cosecant squared x times the product of cotangent x plus cosecant cubed x. Okay, I hope I wrote it right. Cosecant square fourth x times cotangent x, is that the same as cosecant squared x times cotangent x plus cotangent cubed x? All right. And again, to me, the left, goodness, I'm sorry, folks. This past weekend, we were over at the farm in Georgia, and we burned a lot of sticks and stuff that we had been accumulating over time. It was great weather for burning, so we burned a lot of that. However, I breathed too much smoke. Now my throat is so raw I can hardly talk. We were also outside, the temperature dropped, and so I probably picked up a little bit of a head cold too. So I'm not doing all that well as far as speaking goes. So sorry if the voice is pretty rugged here. Okay. And it hurts. Okay. So the left-hand side is fairly simple. If I were going to do anything to it, I would get it all in terms of sines and cosines, but it looks like we can probably deal without that. So let's just deal with the right-hand side now. Okay. Now the cosecant squared x we're going to leave alone. Cosecant squared x. Now, I can factor out of this a cotangent x. Okay. And what are you left with? 1 plus cotangent squared x. My phone's ringing downstairs, but it'll just have to ring. Okay. Now, let's go back to our good old Pythagorean identity. Okay. And that was sine squared x plus cosine squared x, it's supposed to be an O there, is equal to 1. Okay? Now here we got a cotangent squared x. What is cotangent squared? That's cosine over sine. So let's divide everything by sine squared x. And this is just really lousy writing. Over sine squared x. And this is over sine squared x. Alright, so this becomes 1 plus cotangent squared x is equal to cosecant squared x. Well, there's your 1 plus cotangent squared x is cosecant squared x. So this becomes a cosecant squared x that they gave us. This we factored out 1 cotangent x. And this 1 plus cotangent x is another cosecant squared x. Well, guess what? These two multiplied together gives you cosecant fourth x times cotangent x. And that's exactly what the left-hand side was. Cosecant fourth x times cotangent x. And here is Courtney. Let me get him in. Hold on just a moment. Courtney's here. Let me mark the roll. Courtney is here. Okay, so we're just right now missing Jalen, Azora, Morgan, and Sharika. So hopefully they will be coming in soon. Okay, I know that at least one of them has to work. So I was writing this last thing here, cotangent x. And these two are indeed the same. Didn't know until we got down here they are the same. And the book does it again backwards. Okay, I don't know why they do it the opposite way of me every time, but they seem to do that. All right, any questions? All right, there, after every example there is a checkpoint. There are 2 there. Please do those. The summary is right there at the bottom as well, and that finishes 5.2. Let's do the vocabulary, the top of page 360. Now, I don't know if any of you can see this at the same time you're watching the, excuse me, my throat's hurting so badly. That we're watching the Zoom, but if you can't, I'll read them, try to read them slowly so you can follow this. First question, okay, fill in the blank. An equation that is true for all real values in the domain of the variable is an blank. And if you'll notice, anyone know? Identity, perfect. Number 2, an equation that is true for only some values in the domain of the variable is a blank blank. And this would go back to the very first page in the section, and it's how we started off on page 355. The first example given was that, not really an example, but sine x equals 0. That's not true for every value x. It's only true for some values in the domain of x, and that's called a conditional equation. If it's true for every value of x, then that's called an identity, like you said before. So the number 2 was conditional equation. All right, now numbers 3 through 8 or fill in the blanks from your fundamental trigonometric identity. If you haven't gathered now, they feel like these are pretty important. You haven't been paying attention. What is 1 over cotangent u? 1 over cotangent u. What's the reciprocal of cotangent u? Tangent u. Perfect. Number 4. What is cosine u over sine u? Cosine over sine. Just done it a couple of times recently. In fact, right above there in the upper right hand corner of your screen. With squares there, it's still there. Cosine u over sine u is cosine u over sine u is anybody? Do you see my pen? Cosine x, this is cosine squared x over sine squared x, is cotangent squared x. So if you didn't have the squares there, that would just be cotangent x. Perfect. That's number 4. Number 5, the cosine of pi halves minus u, in other words, the cosine of the complement of u would be the sine u. Perfect. Number 6, 1 plus blank is cosecant squared u. 1 plus blank is cosecant squared u. There it is, right there.
Cotangent.
1 plus cotangent squared u. Perfect, perfect. What is cosecant of negative u? That's an even or an odd situation. What is cosecant of negative u? Negative cosecant u, because cosecant and sine and tangent and cotangent are all odd functions. So that would be minus cosecant of u. How about secant of negative u? What would that be? Not negative, because cosine and secant are your two even functions, so that would just be secant u. Those are even functions. All right, those are your vocabulary on the skills and application. Do any of the odds, 9 through 17. They're all at Calc Chat, 9's at Calc View. Do any of the odds 19 to 23. They're all at Calc Chat, 21's at Calc View. Yes. Is that what page? Is that what you said?
Yes, sir.
Page 360. We're going to go on to 361. So 360 and 361. We're still on 360 now. That would be 25 through 29. They're all at Calc Chat. 27's at Calc View. 31 to 35. They're all at Calc Chat. 33's at Calc View. Any of the odds 37 to 41. They're all at Calc Chat. 41's at Calc View. Then on page 361. 43 should be at Calc Chat. Now that's an error analysis. What they've written there is wrong. They put a big red X there. So don't think that's a correct statement. They're trying to get you to figure out where they made the error. I don't really like those, but they're okay. Any of the odds 45 to 49, they say you might need a graphing utility here. I think you could probably do it on your own. Excuse me, my throat is so sore. Those should all be at Calc Chat. 51 or 53 should both be at Calc Chat. 51's at Calc View. 55 should be at Calc Chat. 57 or 59 should be at Calc Chat. For 57 at Calc View. 61 should be at Calc Chat. 63 and 65 should be at Calc Chat. And you can think about doing 67 or 69. They should both be at Calc Chat. All right, good deal. Any questions on 5.2? Verifying trigonometric identities. Okay. Ugh. I think our thermostat has cut off. Most of the time we're not here in the day. Now we are. This is the first time since it's gotten chillier that I'm noticing the thermostat must have kicked off the heating system, so I'm a little on the cool side, but hopefully that'll get through that. So let's move to 5.3. Okay. And we'll go from current slide. I'll resume the slideshow. Chapter 5 is still analytic trigonometry. 5.3 is solving trigonometric equations. Now, if you want to get the connection here, you use your trig identities to set up to solve trig equations. Okay? The objectives here are to use the standard algebraic techniques to solve trigonometric equations. Okay? I'll explain what they mean by that in just a bit. Solve trigonometric equations of the quadratic type. Solve trigonometric equations involving multiple angles. We'll talk about what they mean by that, and we'll use inverse trigonometric functions to solve trigonometric equations. All right, so the introduction here on page 362. Okay, to solve a trigonometric equation, use your standard algebraic techniques when possible, such as collecting like terms, factoring, and that type of thing. And here's what the deal is. In standard algebraic techniques, you're solving for a variable. Okay? X squared plus 7x plus 3 is equal to 14, or something like that. You're solving for the x. Okay? When you're solving a trigonometric equation, first solve for the trig function, and then turn around and solve for the variable x or theta or whatever it is. So you're one step further removed. First solve for the trig function, and then solve for the variable. Okay. Your preliminary goal in solving for a trigonometric equation is to isolate the trigonometric function on one side of the equation, just like you did when you're solving for a algebraic expression. You want to get the x or whatever your variable is by itself to figure out what its solution is. Sorry. So here we have a trigonometric equation. 2 sine x is equal to 1. Now this is not an identity, obviously. This is a conditional equation. So what would you do? First solve for the sine, and you do that by dividing both sides by 2. And let me see if my pen will do that. In the last class it quit doing that, but let's see if it will now. I cannot find my cursor, my pen. There it is. Okay. So we'll divide both sides of the equation by 2. And here the 2's go out, and you get sine of x is 1/2. Well, now that you solve for the trig function, now solve for the x. What values of x, what angles x will give you a sine? When you take the sine of that angle, will give you 1/2. That would be x equal pi 6th, right? Or any multiple of that, plus 2n pi. Any 2 pi multiple of pi 6, and you'll get that. But that's not the only one. Okay, that's just in the first quadrant. Sine is also positive in the second quadrant, so that would be, yuck, get out of there. I'm going to do it up here. X equal pi 6 short of pi, so that would be 5 pi 6 plus 2n pi. You always have to add the multiples of those in. So either pi 6 in the first quadrant or 5 pi 6 in the second quadrant. Those are the places where sine is 1/2, and then every 2n pi multiple from there on. Okay. So to solve for x, note that the figure below, here you are at pi sixth, and then again at 5 pi sixths. Here and here, your sign is 1/2. Not down here, because that's negative 1/2, but up here. So it'd be every 2 pi from that. So I said plus 2n pi, where n is any integer. A minus 2, a minus 1, a plus 1, a minus 3, a plus 3, a minus 4. Yeah, whatever you've got, it repeats itself every 2n pi. Okay, so you see, first solve for the trig function, then solve for the variable. Okay. Moreover, because the sine x has a period of 2 pi, and that's what I was just saying, there are infinitely many other solutions, and they can be written of. That first one was pi 6 plus 2n pi. The second one was a 5 pi 6. That's in the second quadrant. Sine is 1/2. And that would also be plus 2n pi. Sorry, my throat's hurting so badly. I hope this is going to help and not hurt it. Sometimes I think the sugar does more harm than good, but the carbonation seems to help some. I don't know if it does or not. So anyway, there is your solution. These are called your general solutions because that includes every possible value. Okay. So in the figure below, that's this one. It shows another way to indicate where the sine of x is equal to pi halves. It was equal to 1/2. That's on the unit circle version, and that's when sine of pi 6 is 1/2, and then you go around 2n pi clockwise or counterclockwise, depending on whether the ends are positive or negative. And then, but the other place where it's 1/2 is over here at 5 6 pi, just pi 6 short of pi, and there it also, and then you add your 2n pi's to that one as well. Okay. So any angle that is coterminal with either your pi 6 or 5 pi 6 will also be solutions for that equation. When solving trigonometric equations, you should write your answers using exact values rather than decimal approximations. Now, frankly, I really don't care, but most of the time it's easier to identify those as your pi 6. If it's one of these angles that you know. Now, if you had sine of x is equal to 1/3, there's not one of the angles you know, and then you're going to have to do an approximate angle. Okay, but most of the time, if it's one of these that we know and love, like your pi 6, your pi thirds, your pi fourths, or some of those, yeah, in those cases, usually write what they are. Okay, otherwise you just have a bunch of decimal numbers. Okay, so here's example 1, top of page 363, I believe it is. Yeah. So here we have, solve this one, sine x plus plus root 2 is equal to minus sine x. Okay, now, again, the rule is, general rule, try to get all your trig functions on one side and get anything that's not a trig function on the other side. So what we're going to do here is add a sine x to both sides. Okay, that goes to 0, and subtract a square root of 2 from both sides. And what do you have then? You have 2 sine x, these add to 0, is equal to those added to 0 minus square root of 2. Okay, what you're trying to do is solve for your trig function, sine x, so we're going to divide both sides by 2, and that then gives you that the sine of x is equal to minus root 2 over 2. That's again one of the angles that we know and love and we're really familiar with. Now, notice here the sine is negative. Sine is negative in the third and fourth quadrant. Okay? Now, where is sine associated with root 2's over 2's? Those are at your quarter pies. So this will be the quarter pi in where pike force is your reference angle in the third quadrant and the fourth quadrant. So that's going to be 5 pi force. Okay, if I could get my pen to write, x is equal to 5 pi force. That's down in the third quadrant because 4 pi force would be the horizontal line, and 5 pi force would be 1/4 pi beneath that, and this will be plus 2n pi. Or in the fourth quadrant, that would be 7/4 pi plus 2n pi. Okay, that's 1/4 pi short of 2 pi or 8/4 pi. So those are your two general solutions for that trig equation. Does that make sense? Okay. Now I think what I'll do is clear my scratch off the screen here. Well, I can't do that with my finger. I need to do it with the pen. Okay, we're going to erase all that, and let's see how they did it. Begin by isolating the trig function on one side of the equation. So they didn't do it. They wrote the equation again, which is really great. Add a sine x to both sides, and then we'll subtract root 2 from both sides. So that gives you 2 sine x plus root 2 equals 0. Then subtract why don't they add those together? I don't know. 2 sine x equal minus root 2. And that's what we get here, combining like terms, and then divide both sides by 2, and you get sine x is equal to minus root 2 over 2. Now, it solves for your trig function. Now we need to figure out what angles x make that a true statement. Okay? And again, sine is negative in the third and fourth quadrant. It's positive in the first and second, so it has to be either in the third or fourth quadrant, and that would be at reference angle pi force in the third and fourth quadrant, which would be 5 pi force or 7 pi force. Because sine has a period of 2 pi, first find all the solutions in the interval 0 to 2 pi, and that would be third and fourth quadrant. And the two angles, like I said, were at 5 pi force and 7 pi force. Finally, add the multiples of 2n pi to each of the solutions to obtain the general form x equals 5 pi force plus 2n pi, x equals 7 pi force plus 2n pi, where n is any integer, positive or negative. And I'm cold. I think what I'm going to have to do is turn up the heat a little bit, so because my throat's just getting sore and shorter. Hold on just a moment. Let me adjust the thermostat out in the hallway. I'll be right back. Trying to pause the recording, but I can't seem to get it to move. Okay, so there's example 1. Any questions on example 1? All right. And it's not advancing, so I have to click again. All right. They're skipping example. Oh, and by the way, after every example, there is a checkpoint, so please do the checkpoint. And then they're skipping example 2, 3, 2 and 3. So let's do 2 and 3. All right, I think I'm going to have to hold the book in my lap because I have too much trouble seeing it. All right, here we have, let's go back a slide and go to our whiteboard. And we'll clear that. Does anyone need that a little bit longer? Okay. So, it says solve this equation. Sine x, and this is writing really poorly, plus root 2. Wait, that's the one we just did. Example 2. Sorry about that. Okay. Example 2. 3 tangents. I'm sorry, my throat is so sore. 3 times the tangent squared of x minus 1 is equal to 0. Okay. Now, we're trying to solve the equation. Okay. Now, there are a couple of approaches here. I think I'll do the simpler approach first. It's one that can cause you problems, so be careful with it. But we'll just isolate the tangent. Okay? So what we'll do first is add 1 to both sides. Now you can do this. This is no longer verifying identities. We're solving conditional equations. So now you can do this same thing to both sides. You can cross the equal sign. Back in the last section we didn't do that because you're verifying identities. Now we can do that. Okay? So what happens here, these add to 0 and you get 3 times tangent squared x is equal to 1. Now isolate the tangent, not the variable yet, the tangent first, divide both sides by 3. Okay? Now these go out and you have tangent squared x is equal to 1/3. Well, now at this point, take the square root of both sides. Now that's where things get a little trickier, but it's okay, I think, to do that. Okay, so now we have tangent x is equal to, but when you take the square root of both sides, you have to do a plus or a minus. Okay, square root of 1 is 1, and the square root of 3 is the square root of 3. Okay, now we go for the x. After you've isolated the trig function, now go for the variable. Okay, so what variable, when you take the tangent of it, what angle when you take the tangent of it, do you get either a plus or a minus 1 over root 3? Well, I don't know if you like your little triangles. Obviously, I like little triangles. Okay, now this probably isn't drawn to scale. What is tangent? It's opposite over adjacent. So this would be 1 over root 3. Or minus 1 over root 3. We'll worry about that in a minute because you can do that as well. Well, what would this be then? 1 squared plus root 3 squared, that would be 1 plus 3 would be 4, so this makes that 2. Well, what angle is it if this is the angle x, what angle is that true for? That's true for x equal pi sixth. Okay? Because sine is 1/2, you know, all that. So x is either pi sixth plus, now remember tangent has a period of pi. Okay, not 2 pi. So this would be plus n pi. Okay, that puts you over here in the first quadrant or over here in the third quadrant. But it's minus 1 over root 3 in the second quadrant, which would be 5 pi 6 plus n pi. So those are your complete solutions for this one. This is example 2, and you get pi 6 plus n pi, or 5 pi 6 plus n pi. These are the ones where you're positive. These are the ones when you're the negative 1 over root 3. Now they went as far as saying square root of 3 over 3. If you recognize that better, go for it. Same answer. I just assume stay with 1 over root 3. It's a little bit simpler. Okay. There is a checkpoint. Please do the checkpoints. Okay. Any questions on example 2? Okay. Let's see if we can get 3 done. So if it's all right, if there are no questions, I'm going to clear example 2, move to example 3. Everybody okay with it? All right. How about this one? Cotangent x times cosine squared x is equal to 2 cotangent x. Now that one's a little different. Why? Because you have 2 different trig functions, so it's going to be hard to isolate the trig function. You got 2 of them, but it may not be impossible to do. Now there's a couple things that I usually like to try first. Now one thing that may come to mind, if you divide both sides of the equation by cotangent x, you eliminate the cotangent x, and then you have the just cosines there. But by dividing by that, you have to make sure you don't divide by 0, okay? Because that would not be good. You can't divide by 0. So my next guess would be, let's get everything in terms of sine or cosine. Okay, we already got a cosine here, so this would be cosine x over sine x. That's what cotangent is, times cosine squared x, and that's equal to 2 times cosine x over sine x. Okay. Now, this doesn't seem fair either, but you could multiply both sides of the equation by sine x, which was almost as bad as dividing both sides of the equation by cotangent x, because when you divide by cotangent, you have to avoid the zeros. If you're multiplying both sides by sine, you also are, well, sine can't be 0, so you're not wiping out everything. So basically what you got here is cosine cubed x is equal to 2 times cosine x. Okay, now let's do it this way. Subtract 2 cosine x from both sides. And that gives you cosine cubed x minus 2 cosine x is equal to 0. So this will be factor out of cosine cosine x times I'm sorry cosine squared x minus 2 is equal to 0. Well, that gives you either cosine x equals 0 or cosine squared x minus 2 is equal to 0. One or the other. Well, where is this true? That's every half pi. So if x is pi halves and because it's periodic, normally we would say it's periodic with 2n pi, but because these are exactly pi away from each other, that would be plus n pi. Okay. Now, on this side, we have that cosine. Well, I'll go on and do it this way. It's probably not the best way, but I'll do it this way. Cosine squared x is equal to 2. Added 2 to both sides. Okay. Then take a square root of both sides and you get cosine x is equal to plus or minus. You got to always include that, the square root of 2. Okay. Well, we got a problem, don't we, Houston? Because cosine is never equal to root 2 or minus root 2, because cosine is only defined between -1 and 1. So root 2 is greater than that. So either I made a mistake here or in one of my calculations. Let's see what they did. Yeah, they threw out, there's no solution exists for cosine equal plus or minus root 2 because they're outside the range. So yep, we got it right. These, no solution. And this is your only solution. Okay. And that's what they got as well. There is a checkpoint. That's bottom of the page. Please do the checkpoints. All right, and I think we just ran out of time, didn't we? We go to 11:15. I think it just happened. So we'll pick up next time equations of a quadratic type on page 365. Let's find some homework exercises to do from this section, and that would include, this is a fairly long section, any of the odds 5 through 9, they're all at Calc Chat. Any of the odds 11 through 27, they should be at Calc Chat. 13 should be at Calc View. And you can try to do 29 to 37. They're a bit easier because they're limiting to your portion of the domain. They should all be at Calc Chat. 29 should be at Calc View. But stop there and we'll pick up the rest of those next time. Okay. Any questions? All right, folks, if you haven't voted yet and you're eligible to vote and registered to vote, please do so today. Get it done. This is important, really important. So take care. Any questions? I'll stop the sharing for now, and unless there are any other questions or issues, I'm going to end the recording for everybody. Any questions? All right, then we'll end it for all. We'll see you on Thursday, okay? Take care.